The universe holds worlds stranger than fiction. A planet where the sky rains shards of molten glass. Another where a single year passes in just 18 hours. These are not scenes from a movie, but real discoveries in the vast darkness beyond our sun. We have found over 5,000 exoplanets, and their diversity shatters every expectation of what a planet can be. By the end of this journey, you will have explored 25 of the most bizarre worlds ever confirmed, from glittering diamond cores to planets being eaten alive by their own stars. How did a planet survive the explosion of its sun, and what world is so dark it absorbs almost every single ray of light? Each discovery forces us to rewrite the cosmic rulebook and reimagine the very nature of reality. What do you think a planet is truly capable of? Our journey begins with a world of deceptive beauty. From a distance, the planet HD 189733b appears as a serene, deep cobalt blue dot, a tranquil marble suspended in the blackness of space. This color comes from silicate particles, fine grains of sand and glass, suspended high in its atmosphere. But this is no peaceful ocean world. Approach closer, and the serenity dissolves into a nightmare. This is a gas giant, a planet without a solid surface, locked in a death grip with its parent star. It orbits so close that a single year, one complete trip around its sun, takes just over 2 Earth days. The star's gravitational pull has locked the planet in place, so one side forever faces the blistering heat while the other is trapped in eternal night. This creates a furnace of unimaginable violence. Temperatures on the day side soar to nearly 2,000 degrees Fahrenheit, hot enough to melt steel. The extreme heat vaporizes those silicate particles in the upper atmosphere. Then, ferocious winds take over, winds that scream across the planet at over 5,000 miles per hour, many times the speed of sound here on Earth. These are not gentle breezes, but supersonic hurricanes that carry the vaporized glass to the cooler night side. There, the silicate condenses, it hardens. And it falls. This planet does not have gentle rain. It has a perpetual horizontal storm of molten glass shards moving at thousands of miles an hour. Anything or anyone unfortunate enough to be there will be instantly flayed by a scalding, sandblasting hail of razor-sharp glass. Scientists discovered this world using the transit method, watching for the tiny, regular dip in the star's light as the planet passed in front of it. That small flicker of shadow revealed a realm of stunning horror, a beautiful blue jewel that is, in truth, a cosmic slaughterhouse. It stands as a powerful reminder that in the universe, appearances are often a deadly lie. What other deceptions are waiting for us out there in the dark? If the glass rain of HD 189733b represents a beautiful lie, the next planet reveals a treasure that might be brutally real. Welcome to 55 Cancri E, a world that could quite literally be a jeweler's fantasy. It orbits a sun-like star so close that a single year there lasts a mere 18 hours. This proximity creates a gravitational lock, meaning one side of the planet permanently faces its star, a scorching hemisphere of perpetual daylight, while the other is an endless, frigid night. But the true wonder lies beneath its surface. 55 Cancri E is classified as a super-Earth, a rocky planet with about twice Earth's diameter and over 8 times its mass. That immense mass, combined with the crushing gravitational pressures from orbiting so close to its star, is the key to its potential fortune. Spectroscopic analysis of its parent star revealed an unusually high abundance of carbon, the same element that forms coal, graphite, and, under the right conditions, diamond. Scientists theorize that the planet itself formed from this carbon-rich material. The intense heat and unimaginable pressure inside this super-Earth's core are thought to have done something extraordinary. They are believed to have crystallized a significant portion of that carbon, transforming it. The interior of 55 Cancri E, according to this leading theory, is not a molten iron core like Earth's, but a glittering planet-sized diamond. Not just a few carats, but a core potentially 3 times the size of our entire planet made of solid diamond. The surface, however, is no place for a gem collector. The Dayside, constantly baked by its nearby star, is believed to host a global ocean, but this is no water ocean. Temperatures there are estimated to exceed 4,000 degrees Fahrenheit, hot enough to melt rock and metal. So the leading hypothesis is that the sunward face of this diamond world is a churning, incandescent sea of molten lava, a permanent planetary-scale volcano. The controversy, of course, is whether the diamond core theory is correct. Some models suggest the planet could have a thick atmosphere or a more silicate-rich composition, which would mean less diamond. Yet the possibility remains tantalizing. This creates a world of stark, impossible contrasts. One hemisphere could be a seething, hellish lava landscape, while directly beneath it, spanning the entire planet, rests a fortune beyond all human comprehension. It is a world where apocalyptic violence sits atop unimaginable wealth, a cosmic paradox spinning around its star every 18 hours. What does such a world tell us about the raw, untamed ingredients of planetary formation? The glittering diamond core of 55 Cancri E speaks of a planet forged under immense pressure, but some worlds are not just forged, they are actively unmade. WASP-12b is a planet in its final, agonizing death throes, offering astronomers a front-row seat to a cosmic feast. This is a hot Jupiter, a gas giant like our own Jupiter, but it orbits its parent star so close that one entire year passes in just over one Earth day. This proximity has sealed its fate. The star's immense gravity does not just hold the planet in orbit, it actively pulls the planet's atmosphere away, stretching it into a vast, swirling stream of superheated gas. Every single year, the star consumes about 189 quadrillion tons of the planet's material. To put that incomprehensible number into perspective, that is the equivalent of stripping away the mass of 3 entire Earths every single decade. This relentless theft has deformed the planet itself. WASP-12b is not a sphere. The gravitational pull from its star is so extreme that it has stretched the planet into the shape of an egg, a distorted, bloated world being torn apart from the outside in. Its surface temperature is a blistering 4,000 degrees Fahrenheit, hot enough to vaporize iron. The planet is so close that it raises a tidal bulge on the surface of its own star, a literal gravitational hill on the sun's fiery face. We are witnessing the final chapter in this planet's life, a slow-motion destruction that will see its entire atmosphere siphoned away, leaving behind only a stripped, scorched core. It is a tragic and violent process, but for scientists, it is an invaluable lesson. Watching WASP-12b die teaches us about the complex gravitational dances between stars and planets, and the delicate balance that determines whether a world endures or is consumed. It forces us to ask, is our own solar system's peaceful arrangement the rule, or is this kind of stellar violence more common than we think? While WASP-12b is being devoured by a single star, other planets enjoy a more balanced, if far more complex, relationship with their suns. Kepler-16b is a world that does not have one sunset but 2. This is the first confirmed planet ever discovered orbiting not a single star but a pair of them, a circumbinary planet. For any fan of science fiction, the comparison is immediate and thrilling. This is a real-life Tatooine, the iconic twin-sun world from Star Wars. The reality, however, is even more fascinating than the fiction. The 2 stars, Kepler-16 and b, are a cosmic dance partners. One is a smaller, cooler orange dwarf star, and the other is a tiny, dim red dwarf. They orbit each other, pirouetting around a shared center of gravity, completing a full dance every 41 days. And orbiting them both at a safe and stable distance is the planet Kepler-16b. For a long time, astronomers wondered if the chaotic gravitational environment of a binary star system would ever allow planets to form at all. The competing pulls of two suns, they thought, might scatter the dust and gas needed for planet formation or destabilize any world that dared to orbit. Kepler-16b proved them spectacularly wrong. Its discovery showed that planets can not only form in these complex systems, but they can find remarkably stable orbits. The key is distance. Kepler-16b orbits far enough out from the binary pair that it effectively feels the combined gravity of both stars acting as a single central point. It is like swinging a ball on a string around your head. Your hand is the central point of gravity, even though you have two separate arms. From the hypothetical surface of this world, the sky would be a spectacle unlike any in our solar system. Two stars of different sizes and colors would chase each other across the heavens, casting ever-changing double shadows. There would be times when both stars are visible, creating a permanent, eerie twilight even at midday. There would be eclipses as one star passes in front of the other, causing sudden, dramatic dips in brightness. And yes, there would be those legendary double sunsets with two orbs sinking below the horizon in a symphony of light. The catch, of course, is that Kepler-16b is not a desert world like Tatooine. It is a cold gas giant roughly the size of Saturn, with no solid surface to stand on and watch those sunsets. Its surface temperature is a frigid -100 degrees Fahrenheit, but its existence is the important part. It shattered a major assumption and opened our eyes to a whole new category of planetary systems. If a gas giant can form here, could a rocky, Earth-like world also find a stable orbit in a binary system? The discovery of Kepler-16b transformed science fiction into science fact, and in doing so, it revealed that the universe's creativity far exceeds our own imagination. The serene double sunsets of Kepler-16b offer a celestial light show, but our next destination is a place where light itself goes to die. TRES-2b holds the ominous title of the darkest planet ever discovered in our galaxy, a gas giant that reflects less than 1% of the light that falls upon it. To understand just how profound that darkness is, consider a piece of coal, black and lightless. TRES-2b is blacker. Imagine fresh asphalt on a moonless night, absorbing nearly every photon. This planet is darker still. It is not merely a dark gray or a deep blue. It is an almost perfect black body, a cosmic void that swallows starlight whole. This profound darkness was discovered not by seeing the planet, but by noticing its profound absence of light. Astronomers used the Kepler Space Telescope to observe the star GC 0354902881. They detected the telltale, regular dimming that occurs when a planet transits or passes in front of its star. But then they looked for the secondary eclipse, the moment when the planet passes behind its star. When a typical, reflective planet like Jupiter moves behind its sun, there is a tiny but measurable increase in the total light we see, because that bright planet's reflected glow is suddenly hidden. For TRES-2b, that increase was almost non-existent. The planet contributed virtually no reflected light to hide. The calculations were startling. This world reflects less than 1% of the light from its parent star, making it blacker than any known planet or natural object in our solar system. So what creates such an abyssal blackness? The leading theory points to a horrifyingly exotic atmosphere. TRES-2b is a hot Jupiter, orbiting its star at a distance of only about 3 million miles. Its dayside temperature soars to over 1,800 degrees Fahrenheit. At these infernal temperatures, scientists believe the atmosphere cannot form the bright, reflective clouds of ammonia and water that give Jupiter its banded, creamy appearance. Instead, the atmosphere may be filled with vaporized light-absorbing chemicals. Elements like gaseous sodium and potassium, or even titanium oxide, could be present. These substances do not scatter or reflect light. they greedily absorb it, converting the radiant energy of starlight into more heat, which only makes the atmosphere even hotter and more hostile. The visual effect from space would be deeply unsettling. You would see the star, a brilliant point of light, and a tiny, perfect circular shadow orbiting it, a hole punched out of the cosmos. From a hypothetical vantage point near the planet, the scenery would be a study in absolute contrast. The star would blaze with unbearable intensity in a sky of eternal black, casting sharp, stark shadows. But the planet's own atmosphere would offer no soft glow, no diffuse light. It would be a realm of deepest shadow where the very air seems to drink the light, leaving only an eerie, heat-blasted gloom. TRES-2b is a monument to atmospheric extremes, a world that teaches us that planets are not just passive reflectors of light, but active participants in an energy exchange, and in this case, the exchange is one of total, devouring consumption. A world of perfect darkness gives way to one shrouded in perpetual, steamy twilight. GJ1214b is a super-Earth, a planet about 2.5 times the size of our own, but with nearly 7 times the mass. That extra mass is the first clue to its profound strangeness, hinting at a composition far denser than rock and iron alone. Astronomers have studied this world intensively, and the data paints a compelling, almost surreal picture. This is not a terrestrial planet like Earth or Mars. Instead, GJ1214b is likely a true water world, an entire planet where water makes up more than half of its total substance. Imagine a global ocean, but not one that rests on a rocky crust. Here, the ocean is the planet itself, extending from a steamy, opaque atmosphere all the way down to a core of immense pressure. The atmosphere is thick and hazy, a permanent global blanket that traps heat and scatters light, ensuring the surface, if you could call it that, is a place of diffuse, murky gloom. The temperatures are estimated to be in the hundreds of degrees Fahrenheit, far too hot for liquid water as we know it to exist on the surface. But this is where the ordinary ends and the exotic begins. Under the crushing weight of a planet spanning ocean dozens of miles deep, the physics of water changes completely. At the lower depths of this alien sea, the pressure is millions of times greater than at the bottom of Earth's Mariana Trench. Under such conditions, water is forced into states that seem like science fiction. Scientists speculate about the existence of hot ice, a crystalline form of water known as Ice 7 or Ice 10, that remains solid even at temperatures of hundreds of degrees, simply because the pressure is so unimaginably high. Elsewhere in that dark ocean, water might become a superfluid, a substance with zero viscosity that can flow without any friction, creeping up the sides of its container and defying our basic understanding of liquids. This presents a profound challenge for life as we know it. There is no solid land, no sunlight, no mineral-rich hydrothermal vents like those that support life in Earth's deep oceans. Any potential chemistry for life would have to occur suspended in a vast, pressurized abyss or at the vague boundary where the steamy atmosphere meets the ocean surface. Yet, despite these seemingly hostile conditions, GJ1214b remains a jewel for planetary scientists. Its thick, extended atmosphere, while opaque to our current telescopes, is a perfect laboratory for future study. As instruments improve, astronomers hope to peer into that haze, to analyze its chemical makeup, and understand the complex interactions between a global ocean and a planet's air. It represents a whole new class of world, one that is neither terrestrial nor gaseous, but aquatic on a planetary scale. It forces us to expand our definition of an ocean from a surface feature to the very essence of a world. From a world cloaked in steamy haze, we turn to a planet of stark, unforgiving fire. Kepler-10b is a landmark discovery, one of the very first rocky exoplanets ever confirmed beyond our solar system. This is not a gas giant or a water world, but a terrestrial planet, a cousin to Earth in its basic rocky composition, yet the resemblance ends there. Kepler-10b orbits its Sun-like star with a frantic, blistering proximity. 1 year on this world, one complete orbit takes a mere 20 hours. This extreme closeness has doomed it to a truly infernal fate. The planet is tidally locked, meaning one hemisphere permanently faces the star's fury, while the other is turned forever toward the cold void of space. The dayside temperature is estimated to exceed 2,500 degrees Fahrenheit, hotter than a blast furnace. At such heat, rock does not simply melt, it flows. The leading theory, supported by observations, is that the entire sunward face of Kepler-10b is a single, global ocean of molten lava. There are no continents, no mountains, no solid ground, only a churning, incandescent sea of liquid rock, constantly stirred by the star's intense heat and radiation. What makes this world particularly fascinating to scientists is its incredible density. Measurements of its mass and size reveal that Kepler-10b is far denser than Earth. This suggests an interior dominated by heavy elements, most likely an iron-rich core that makes up a staggering proportion of the entire planet. It may be a world with a relatively thin mantle of rock over a monstrous ball of molten metal, a structure that gives it extraordinary weight for its size. The most haunting visual, however, would be found in the perpetual twilight zone, the narrow band between eternal day and endless night. Here, where the star sits perpetually on the horizon, temperatures might be just low enough for the lava to begin to solidify. One can imagine a rugged, jagged shoreline of black volcanic rock, constantly being melted and refrozen by the relentless thermal tides. It would be a landscape of terrifying beauty, a razor's edge between a sea of fire and an abyss of frozen darkness under a sky dominated by a bloated, angry sun. Kepler-10b stands as a brutal reminder. The discovery of a rocky world was a milestone, a sign we could find places like home. But this world showed us that being terrestrial does not mean being habitable. It can also mean being a vision of pure geological hell, a cautionary tale written in molten stone and iron. The searing lava oceans of Kepler-10b exist in a tight, scorching embrace with its star, but at the opposite extreme of cosmic real estate lies a world of profound isolation. HD 106906b is a mammoth, a planet with 11 times the mass of Jupiter, yet it orbits its host stars at a distance so vast it defies belief. Picture our own solar system. The Earth is one astronomical unit from the Sun. Neptune, the most distant major planet, is about 30 astronomical units out. This colossal world, HD 106906b, is not 30, not 100, but over 730 astronomical units from its twin suns. At that distance, a single orbit takes an agonizingly slow 15,000 years. From the planet's perspective, its parent stars would not be blazing suns dominating the sky, but merely two exceptionally bright stars, a pair of faint, close-together pinpricks in an otherwise black and starry void. This staggering separation is the central mystery. According to standard models of planet formation, giant worlds like this are built close to their stars in the dense, warm inner disk of gas and dust. They should not exist in such empty, frozen remoteness. So how did it get there? Astronomers have two compelling and equally dramatic theories. The first is that HD 106906b is not a planet in the traditional sense at all, but a failed star. In a binary system, sometimes the process of stellar formation can be uneven, leaving one object with too little mass to ignite the fusion fires in its core. This planet could be a brown dwarf, a substellar object that formed alongside its companions but never truly shone. The second theory is even more thrilling. This world may have formed much closer to its stars, but a gravitational encounter, perhaps with another giant planet, acted like a cosmic slingshot. This violent event could have kicked it out into a wildly elongated orbit, sending it hurtling to the very outer darkness of its system, a planetary exile on an epic scale. Its discovery forces us to confront the chaotic youth of planetary systems, where gravitational battles can fling worlds into the deep freeze, creating lonely giants adrift in the immense spaces between stars. What other orphans might be lurking in the perpetual night between suns? The lonely giant HD 106906b exists in a frozen exile, but the first planets ever found beyond our sun orbit a corpse. In the constellation Virgo, a cosmic lighthouse known as PSRB 1257+12 blinks with metronomic precision. This is not a star in any conventional sense, but a pulsar, the super-dense, rapidly spinning remnant of a massive star that died in a cataclysmic supernova explosion. It is only about 12 miles across, yet contains more mass than our entire sun, spinning over 160 times every single second. And in 1992, astronomers Alexander Wolskson and Dale Frail made an earth-shattering discovery. This dead star was not alone. Tiny, rhythmic variations in its incredibly precise pulses revealed the gravitational tug of not one, but 3 worlds orbiting it. These were the very first confirmed exoplanets in history, planets orbiting a stellar zombie. The environment they inhabit is the most hostile imaginable. The pulsar's surface is a crust of iron 10 billion times stronger than steel, and its magnetic field is a trillion times more powerful than Earth's. As it spins, it beams out cones of intense radiation, gamma rays, X-rays, and high-energy particles that sweep across space like the blades of a cosmic lighthouse. Any planet caught in that beam is sterilized, scoured clean by a torrent of energy that would rip apart molecules and strip away atmospheres in an instant. So how can planets possibly exist here? Their very presence is a profound mystery, a story of cosmic resurrection. The leading theory is that these are not survivors of the supernova. No ordinary planet could withstand that apocalypse. Instead, they are likely second-generation worlds forged from the ashes. When the original star exploded, it would have utterly destroyed any existing planetary system. But the debris field from that explosion, a swirling disk of heavy elements and dust, remained. From this graveyard of a star, new planets coalesced. They are worlds born from death, constructed from the exotic remnants of stellar nucleosynthesis elements like iron, gold, and uranium. What would it be like on the surface of such a zombie world? The sky would be dominated by the pulsar, a tiny, blinding point of light flashing on and off with machine gun rapidity, casting strobing, disorienting shadows across a barren landscape. There would be no warmth from that dead sun, only lethal radiation. The ground itself might be composed of crystalline metals or strange alloys forged in the supernova fire. These pulsar planets are smaller than Earth but unimaginably dense. They are testaments to resilience on a cosmic scale, proving that even in the aftermath of total stellar destruction, the universe can find a way to rebuild, creating new and unthinkable worlds from the dust of the old. The pulsar's sterile, metallic worlds are born from destruction, but another planet is actively being unmade by its own atmosphere. Co-Rho T7b presents a vision of geological apocalypse so intense it creates weather from stone itself. Discovered in 2009, this is a super-Earth, a rocky world with about 5 times the mass of our own, but it orbits so close to its sun that a year passes in a mere 20 hours. This proximity has created the most extreme temperature dichotomy we have ever observed on a solid planet. The day side, permanently locked facing the star, is a furnace exceeding 4,000 degrees Fahrenheit. At this heat, the very bedrock does not just melt, it sublimates. Solid rock turns directly into vapor, rising from the scorching surface to form a thin, tenuous atmosphere not of oxygen or nitrogen, but of vaporized silicates, minerals like enstatite and forsterite. Imagine the air itself being made of the ghost of vaporized mountains. Now follow this mineral mist as it is carried by fierce winds toward the night side, the hemisphere condemned to perpetual airless night. Here, temperatures plummet to a bitter negative 330 degrees Fahrenheit. In that deep freeze, the mineral vapor cannot remain a gas. It condenses, it solidifies, and it falls, but this is not gentle snow. The particles coalesce into tiny pebbles and granules of rock that rain down from the black sky. Scientists describe this as a precipitation of rock snow, a relentless, gritty hail that accumulates on the frozen volcanic plains below. The landscape this creates is one of surreal and violent contrast. The dayside is likely a global ocean of molten lava, constantly evaporating and replenished by volcanic activity from the planet's tortured interior. The terminator line, the border between day and night, would be a jagged, terrifying shoreline where flowing lava meets a growing beach of dark, metallic pebbles. Over eons, this bizarre cycle could even be reshaping the planet itself, slowly transporting material from the hot hemisphere to the cold one in a slow-motion conveyor belt of stone. Co-Rho T7b is a world where the very concept of weather is rewritten. There are no water clouds here, no thunderstorms or gentle rains. Instead, the sky rains the building blocks of the planet's own crust in a perpetual, silent storm that turns geology into meteorology. If this is what happens to a rocky world that ventures too close to its sun, what other alchemical transformations are waiting to be discovered? The relentless stone rain of Co-Rho T7b is a stark vision of a world pushed to its absolute limit, but the universe holds more than just cautionary tales. Amidst the fire and ice, astronomers also search for islands of possibility, places where the delicate balance for life might just hold. That search found its first great symbol with Kepler 22b. In 2011, the announcement of this world sent a ripple of genuine excitement across the globe. It was the very first planet discovered by the Kepler Space Telescope that orbited squarely within the habitable zone of a Sun-like star. The habitable zone, often called the Goldilocks zone, is that narrow band around a star where temperatures are just right, not too hot and not too cold, for liquid water to exist on a planet's surface. And liquid water, as we understand it, is the fundamental ingredient for life. Kepler 22b was not a scorched lava world or a frozen giant, but a candidate for something profoundly familiar. Orbiting a star slightly smaller and cooler than our Sun, this planet completes a year in about 290 days. Its position suggested a possible equilibrium, a world where sunlight could provide warmth without creating a furnace. The planet itself is a super-Earth with a radius about 2.4 times that of our own world. That size places it in a fascinating category, larger than the rocky planets of our inner solar system but smaller than the gas giants. The critical unknown, the great mystery of Kepler 22b, is its composition. With its current data, we cannot see its surface or directly analyze its atmosphere. Scientists have modeled several possibilities. It could be a rocky world with a substantial atmosphere, a mini Neptune shrouded in thick gas and hydrogen, or perhaps most intriguingly, a global water world. A planet of its mass and diameter could easily be composed of a significant fraction of water, potentially covered by a planet-wide ocean hundreds of miles deep. While that presents its own challenges for life as we know it, the very possibility was transformative. Kepler 22b did something crucial. It provided the first concrete proof that planets of the right size, in the right place, around the right kind of star, were not just theoretical, they were out there waiting to be found. It transformed the search for Earth-like worlds from a philosophical question into a statistical certainty. This single discovery told us that the galaxy's menu of habitable environments was far more diverse than our own solar system had suggested. A life-bearing planet did not have to be a twin of Earth. It could be a larger super-Earth with stronger gravity, or a world orbiting a cooler, dimmer star, or an ocean planet with no continents at all. Kepler 22b became a beacon of hope, a demonstration that amidst the cosmic strangeness, the conditions for life might be woven into the fabric of the galaxy itself. It opened the door to a new era of questioning. If a world like this could exist so readily, what even more perfect matches might be hiding in the data, and what would life make of a home under a gentler, yellower sun? Kepler 22b offered a vision of serene possibility, but the cosmos is also a sculptor of spectacle on a scale that defies comprehension. J1407b presents us not with a potentially habitable world, but with a celestial masterpiece of shadow and light. Observations of its parent star revealed something bizarre. The star's light would occasionally dim in a way that was utterly unlike the clean, symmetrical dip caused by a simple planet. Instead, the dimming was chaotic, complex, and asymmetrical, with multiple drops in brightness that lasted for weeks. The only plausible explanation was a series of vast, opaque rings passing in front of the star, rings belonging to an unseen, massive object orbiting it. The scale of this ring system is staggering. Saturn's magnificent rings span about 280,000 kilometers at their widest. The rings around J1407b, if that is indeed what they are over 120 million kilometers in diameter. That is nearly the distance from the Earth to the Sun. This ring system is so colossal it makes Saturn's look like a child's toy. The object at the center of this cosmic carousel is itself mysterious. It is likely either a gas giant planet dozens of times more massive than Jupiter, or a brown dwarf, a failed star. This central body would be the anchor for rings composed of countless particles of dust, rock, and ice, stretching across an expanse of space so vast it is difficult to truly picture. The eclipses caused by this structure would be a breathtaking, month-long celestial drama. From a hypothetical moon within this system, the sky would be dominated by these colossal rings, arching across the heavens like a glittering, segmented bridge. They would cast deep, complex shadows upon the central world, creating zones of perpetual twilight that would sweep across its cloud tops. As different segments of the rings, with their varying densities and gaps, passed between the moon and the star, the sunlight would flicker and dance in an ever-changing pattern of dimness and brilliance. It is a dynamic, living sky of a kind we can scarcely imagine, a permanent light show engineered by gravity on a galactic scale. The very existence of such a structure raises profound questions. Are we seeing a young, still-forming planetary system where moons are coalescing from this vast disk of debris? Or is this the aftermath of a cataclysmic collision, a shattered world whose remains now form a memorial in orbit? J1407b, whether planet or brown dwarf, reminds us that the architecture of solar systems can be far more elaborate and ornate than our own, turning a simple orbit into a theater of shadows on the grandest possible stage. While J1407b dazzles with its colossal rings, another discovery from the same year revealed a world of profound and silent cold. Ogle 2005 BLG390LB is a frozen super-Earth, a planet that exists at the absolute opposite end of the thermal spectrum from the blazing lava worlds we have visited. This world was not found by watching for a transit in front of a bright star, but through a far more subtle and rare cosmic trick called gravitational microlensing. Here is how it works when a massive object like a star passes directly in front of a more distant star from our viewpoint. Its gravity acts like a lens. It bends and magnifies the light from the background star, causing a temporary, characteristic brightening. If the foreground star has a planet orbiting it, that planet's own tiny gravitational field adds a brief, telltale spike or wiggle to the light curve. It is an incredibly difficult observation, like detecting a firefly's shadow on a searchlight from thousands of miles away. But in 2005, that is precisely what astronomers did. They caught the signature of this distant world, one of the very first super-Earths ever discovered through this method. The data painted a picture of a solitary, frigid orb. Ogle 2005 BLG390LB is estimated to be about 5.5 times the mass of Earth. It orbits a dim, cool red dwarf star at a distance roughly 3 times that between Earth and the Sun. But because its sun is so faint, that orbit places it in a state of permanent deep freeze. The surface temperature is calculated to be a staggering negative 364 degrees Fahrenheit. That is only about 50 degrees above absolute zero, the temperature where all molecular motion theoretically stops. At such cold, the very air we breathe would freeze solid into a blanket of snow. The planet's composition is thought to be a mixture of rock and ice, a terrestrial world where water exists only as permanent, glacier-hard bedrock, and where the atmosphere, if it has one at all, has long since collapsed and frozen onto the surface. From its surface, the parent star would appear as nothing more than a bright, reddish pinpoint in an otherwise ink-black sky, providing no perceptible warmth. This world is a monument to isolation and cold, a reminder that the habitable zone is a razor-thin band in a cosmos filled with frozen wastelands. Its discovery was a triumph of ingenuity, proving we could find small, rocky worlds even around faint stars at tremendous distances. It expanded our map of planetary diversity to include not just hellish infernos and temperate hopes, but also these silent, icy tombs, showing us the full, breathtaking range of temperatures a planet can endure. The silent, frozen tomb of Ogle 2005 BLG 390LB exists in a state of near-permanent stillness, but the universe also hosts survivors of stellar violence on a scale that makes mere cold seem tranquil. The planets Kepler-70b and Kepler-70c are locked in a frantic, scorching dance around the corpse of their sun, a testament to a cataclysm they somehow endured. Their host is not a normal star, but a subdwarf B star, a tiny, intensely hot stellar remnant about the size of Earth but with half the mass of our Sun. This is the exposed, helium-burning core of a star that once swelled into a red giant, a phase that should have spelled certain doom for any nearby worlds. Yet here they are. Kepler-70b holds the record for one of the shortest years ever measured. This blistering world completes a full orbit around its star in just 5 hours and 45 minutes. To put that speed into perspective, a single day on Earth is 4 times longer than an entire year on this planet. Its sibling, Kepler-70c, is only slightly more leisurely, with a year lasting about 8.2 hours. Both are believed to be the roasted, skeletal cores of what were once gas giants, their fluffy atmospheres boiled away by the star's past and present fury. Their very existence is the staggering mystery. When their star exhausted the hydrogen in its core billions of years ago, it ballooned outward into a red giant, expanding to a diameter that would have engulfed the orbits of Mercury, Venus, and Earth in our own system. Standard models say Kepler-70b and C should have been swallowed whole, vaporized and assimilated into the star's outer layers, but they did not vanish. The leading theory is that these planets were massive enough and orbited with enough angular momentum to actually spiral inward as the star expanded. They may have plowed through the star's tenuous outer atmosphere, experiencing unimaginable drag but not complete destruction. This process would have stripped away their gaseous envelopes, leaving behind only their dense, rocky or metallic cores. As the star later shed its outer layers and collapsed down to its hot, blue core, these two survivors were left in their current, impossibly tight orbits. The environment they inhabit now is one of pure, radiative fury. The subdwarf B star blasts out intense ultraviolet light, bathing the planets in a constant, sterilizing glow. Surface temperatures on these worlds are estimated to exceed a searing 6,000 degrees Fahrenheit, hotter than the surface of some stars. They are not worlds in any traditional sense, but planetary ghosts, the immortal cores of giants that dance through the heart of a dying sun and live to tell the tale. Their frantic orbits are a permanent memorial to a stellar apocalypse, a ticking clock that measures years in hours, reminding us that even in the face of cosmic annihilation, some worlds find a way to cling to existence. The frantic survivors of Kepler-70 show that planets can endure stellar death, but Kelt 9b exists in a state of constant, violent birth. This is the hottest planet ever discovered, a gas giant so thoroughly roasted that its dayside temperature exceeds 7,800 degrees Fahrenheit. That is hotter than the surface of many red dwarf stars. Kelt 9b orbits a Blua-type star, a stellar powerhouse that burns twice as hot as our own Sun and blasts out torrents of high-energy ultraviolet radiation. The planet is so close to this stellar furnace that one full year passes in just 36 hours, and it is tidally locked, presenting one face to an endless, blistering day. The heat here is so extreme it fundamentally breaks the chemistry of a planetary atmosphere. On cooler worlds, atoms bind together to form familiar molecules like water, carbon dioxide, and methane. But on the day side of Kelt 9b, the ultraviolet radiation from its star is so intense it acts like a cosmic shredder. It rips these complex molecules apart, dissociating them back into their raw atomic components. The atmosphere is not a blanket of gases, but a swirling soup of individual atoms: hydrogen, oxygen, carbon, titanium, iron, all superheated to a plasma-like state. Metals that would be solid rock on any other world are vaporized here, existing as gaseous elements in the upper atmosphere. In fact, astronomers have detected the signatures of vaporized iron and titanium in its skies, a metallic haze glowing fiercely under the ultraviolet assault. This creates a bizarre and luminous spectacle. The planet is so hot that it glows with its own light, a deep, angry red, like a colossal ember adrift in space. From a distance, it might not even look like a planet at all, but rather a small, misshapen companion star radiating the heat of its own destruction. The stellar wind from its host star is also relentlessly stripping this puffed-up, superheated atmosphere away, creating a vast, comet-like tail of lost material that trails behind the planet in its orbit. Kelt 9b offers scientists a unique and terrifying laboratory. It is a place where the conditions are so extreme they begin to blur the line between planet and star. Studying this world helps us understand the absolute limits of planetary existence, showing us what happens when a gas giant ventures into the forge of a stellar inferno. It is a world not of weather but of atomic disintegration, a permanent flash of creation and annihilation under a blue-white sun. Kelt 9b blurs the line between planet and star, but Gliese 436b defies the very laws of common sense. This world, roughly the size of Neptune, orbits a cool red dwarf star so closely that its year is a mere 2.6 Earth days. Surface temperatures soar to over 800 degrees Fahrenheit, hot enough to melt lead and turn water into a furious, superheated steam. Yet astronomers are convinced this planet is sheathed in a layer of solid water. Not liquid, not vapor, but ice. This is the paradox of the burning ice world. The explanation lies not in the heat but in the crushing force of gravity. Gliese 436b is a massive world with about 22 times the mass of Earth packed into a Neptune-sized sphere. This creates an interior pressure so immense it defies imagination. The gravitational force is so powerful that it compresses the planet's water, even at those scorching temperatures, into an exotic form known as Ice 7. This is not the crystalline ice of your freezer. Ice 7 is a high-pressure polymorph, a state where water molecules are squeezed into a different, denser lattice structure that remains solid under conditions that would instantly vaporize ordinary ice. Imagine a diamond. You can heat a diamond to a high temperature, but under immense pressure it remains a solid diamond. It does not melt into liquid carbon. Gliese 436b's water is trapped in a similar gravitational vise. The planet's fiery surface heat is trying to tear the water molecules into a gas, while the incredible weight of the planet's own atmosphere is pressing down, forcing them into a solid state. The result is a layer of hot ice, a crust of solid water glowing at red heat, possibly enveloping a core of compressed, diamond-like carbon. Adding to the mystery is the planet's atmosphere. Spectroscopic studies show it is losing hydrogen at a tremendous rate, streaming away from the planet like a comet's tail under the relentless glare of its star. Yet somehow the atmosphere persists. This suggests a dynamic, perhaps volcanic world, where internal processes are constantly replenishing the lost gases, a geological engine working overtime to maintain its identity against the stellar wind. Gliese 436b is a world of impossible balance, a place where fire and ice are not opposites, but partners locked in a gravitational stalemate. It teaches us that a planet's true nature is not written in temperature alone, but in the invisible, crushing hand of pressure, sculpting matter into forms that seem to contradict reality itself. Gravity's stalemate on Gliese 436b creates a world of solid fire, but some planets seem to defy gravity's very grip. WASP-17b is a cosmic paradox, a gas giant so vast and bloated it has earned the nickname the Puffy Planet. This world is a true colossus, measuring nearly 100,000 miles in diameter, making it almost twice the width of Jupiter. Yet for all that immense volume, it contains only about half of Jupiter's mass. The math reveals its astonishing nature. Its density is calculated to be a mere 1/10 of a gram per cubic centimeter. That is roughly the density of styrofoam. If you could find an ocean large enough, this entire planet would float. The question is, what force is inflating it like a hot air balloon? The leading theories point to an internal furnace. WASP-17b orbits extremely close to its star, completing a year in just 3.7 Earth days. This proximity creates intense tidal forces, where the star's gravity constantly flexes and stretches the planet's interior. This tidal heating, much like the process that drives the volcanic chaos on Jupiter's moon Io, could be pumping enormous amounts of energy into the planet's core, causing it to expand from the inside out. Another possibility is that the planet retains a tremendous amount of primordial heat from its violent formation, heat that was never able to dissipate because the planet was born so close to its star's warmth. This internal glow acts like a built-in heater, puffing up the atmosphere to its extraordinary dimensions, but the strangeness does not stop with its size. WASP-17b also moves in a profoundly unnatural way. It orbits its star backwards in what astronomers call a retrograde orbit. In our solar system, every planet spins and orbits in the same direction, a legacy of the spinning disk of gas and dust from which they formed. A retrograde orbit is a glaring sign of a violent past. The most likely explanation is that WASP-17b was gravitationally assaulted in its youth. A close encounter with another massive planet, or perhaps a distant stellar flyby, could have acted like a cosmic billiard shot, flipping its orbit and sending it careening in the wrong direction around its star. This single world, therefore, tells two stories of chaos. Its backwards path speaks of a gravitational battle that reshaped its destiny, while its puffed-up form reveals the ongoing, energetic consequences of living too close to a sun. It is a planet of delicate balance, a styrofoam giant held together by its own weak gravity, dancing a backwards waltz under the heat of a star it once defied. How many other gentle giants have been thrown off course in the turbulence of a young solar system? The styrofoam giant WASP-17b is a world of extremes, but the ultimate search is for a world of quiet familiarity. In 2020, data from the retired Kepler Space Telescope revealed a hidden gem, a world that for a moment made the astronomical community hold its breath. Kepler 1649c is a rocky planet almost exactly the same size as our own Earth, a true rarity in the cosmic census. Even more compelling, it orbits squarely within the habitable zone of its small, cool red dwarf star, receiving about 75% of the stellar energy that Earth gets from our Sun. In terms of size and temperature, this is one of the most Earth-like worlds ever discovered. The initial excitement was palpable. Here was a world that was not a super-Earth or a mini Neptune, but a direct cousin in scale, a planet where gravity and sunlight would feel almost like home. From a distance, it fit the profile of a potential oasis, a rocky marble in the not-too-hot, not-too-cold zone where liquid water could pool on its surface. But as with all discoveries orbiting red dwarfs, the devil is in the stellar details. Red dwarf stars are turbulent, temperamental parents. They are prone to erupting with massive stellar flares, sudden outbursts of radiation that can be hundreds of times more powerful than anything our sun produces. A planet like Kepler 1649c, orbiting so close to its dim star to stay warm, would be dangerously exposed to these blasts. Such flares could strip away a planet's atmosphere over time and bathe its surface in sterilizing ultraviolet and X-ray radiation. The second major challenge is tidal locking. Because the planet orbits so close to its star for warmth, it is almost certainly locked, with one hemisphere in permanent daylight and the other in endless night. This creates a world of stark climatic extremes. The day side could be a scorching desert, while the night side might be a frozen wasteland. The most likely region for temperate conditions would be a narrow twilight band, the Terminator line, where the star sits perpetually on the horizon. Here, one could imagine a landscape of eternal sunrise or sunset, with temperatures potentially suitable for liquid water. But could an atmosphere redistribute enough heat to soften these extremes, or would the planet be a world of two harsh, separate faces? Kepler 1649c represents a tantalizing step in the search, a world that matches Earth in the most fundamental metrics of size and location, yet orbits a star that presents a formidable set of survival tests. It is a reminder that finding an Earth twin is not just about the planet itself, but about the long-term stability and temperament of the sun it calls home. The search for an Earth-like cousin reveals just how precious and rare a stable, gentle sun can be. But in the universe's grand art gallery, rarity takes many forms, and some worlds are masterpieces of alien geology. HDP 7b is a hot Jupiter, a gas giant orbiting so close to its sun that its year lasts a mere 2.3 Earth days. This proximity locks the planet, with one side a permanent, searing inferno and the other a cooler but still scorching eternal night. The dayside temperature exceeds 4,000 degrees Fahrenheit, hot enough to vaporize metals and tear molecules apart. Yet it is on the slightly less hellish night side where the true magic and mystery unfolds. Data from the Kepler Space Telescope revealed something extraordinary in the planet's atmosphere. As the planet orbited, astronomers detected a shifting, wandering patch of intense brightness on its night side. This was not a steady glow, but a dynamic, moving feature. The most compelling explanation is the presence of colossal, reflective clouds, but these are not clouds of water or ammonia. At the estimated temperatures on the night side, which still reach over 2,000 degrees Fahrenheit, certain minerals that are solid rock on Earth can exist as vapor in the upper atmosphere. As this mineral-rich air circulates from the blazing day side to the marginally cooler night side, it condenses. Scientists modeling this world believe the condensing material could be corundum, the crystalline form of aluminum oxide. On Earth, when corundum is tinted with traces of chromium, it becomes a ruby. When it contains iron or titanium, it becomes a sapphire. This means the night side of HDP 7b could be shrouded in swirling, glittering clouds of vaporized gemstones. These would not be solid stones, but clouds of tiny, reflective particles, a glittering metallic haze high in the alien sky. The atmospheric dynamics are ferocious. Supersonic winds, powered by the immense temperature difference between day and night, race across the planet, carrying the mineral vapor to the condensation zone. There, the corundum crystallizes out, forming those dazzling clouds, and when the particles grow too heavy, they would fall. The precipitation on this world could be a rain of liquid rubies and sapphires, droplets of molten gemstone that evaporate again as they sink into the deeper, hotter atmospheric layers. It is a breathtaking cycle of creation and destruction, a permanent storm of jewels in a sky dominated by a monstrous, close sun. This world is a stark reminder that the universe's beauty is not always gentle or habitable. It can be a violent, radiant, and unimaginably opulent spectacle, a gemstone tempest raging in the eternal twilight of a giant planet's dark side. The gemstone tempests of HDP 7b are a spectacle of atmospheric alchemy, but some planets have lost their atmospheres entirely, revealing the secrets hidden deep within. TOI 849b is a cosmic anomaly, a world that should not exist according to our standard models of planetary formation. Discovered by NASA's TESS satellite, this planet is roughly the size of Neptune, yet its mass is over twice as great. That immense mass packed into a Neptune-sized sphere gives it a density almost identical to Earth's. This is the critical, baffling clue. A planet the size of Neptune should be a gas giant, a world with a relatively small rocky core enveloped by a massive, fluffy atmosphere of hydrogen and helium. Its density should be low, like that of the puffy planet WASP-17b. TOI 849b is not fluffy at all. It is dense, heavy, and profoundly rocky. So what happened to all the gas? The leading and most dramatic explanation is that we are not looking at a complete planet, but a planetary corpse. TOI 849b is likely the naked, exposed core of a former gas giant. Imagine Jupiter stripped of its magnificent bands of swirling gas, its deep layers of metallic hydrogen, its entire vast envelope. All that would remain is its central core of rock and metal, a lump of primordial planet stuff about the size of Neptune. That is what TOI 849b appears to be. The question becomes one of cosmic violence. How does a gas giant lose its entire atmosphere? Astronomers have two compelling theories, both catastrophic. The first is a slow death by stellar roasting. The planet orbits extremely close to its sun-like star, completing a year in just 18 hours. That proximity bathes it in intense radiation. Over billions of years, the star's fierce ultraviolet light could have boiled away the planet's gaseous envelope, pushing it off into space like steam from a kettle until only the dense core remained. The second theory is far more sudden. A colossal, direct impact with another planet-sized object in the system's chaotic early days could have blasted the atmosphere away in a single, titanic event, a gravitational punch that sent the gas flying into the void. This world is more than a curiosity, it is a unique scientific treasure. We have never been able to see the core of a gas giant directly. In our own solar system, the cores of Jupiter and Saturn are hidden beneath thousands of miles of crushing, opaque fluid. TOI 849b offers a pristine, open book. By studying its composition through spectroscopy, astronomers can, for the first time, directly analyze the building blocks from which giant planets form. What metals and rocks make up the heart of a colossus? What does the seed of a gas giant truly look like? This naked core is a relic of a planetary cataclysm, a stark, heavy monument to the violence that shapes solar systems, and a direct window into the hidden heart of worlds we once thought we could never see. A naked planetary core is a relic of violence, but other discoveries hint at entire new families of worlds waiting to be found. While we have focused on planets, the search has also turned to their companions, leading to a detection that could rewrite the rules of celestial companionship. In 2018, data from the Kepler and Hubble space telescopes pointed to something unprecedented around the gas giant Kepler 1625b. The planet itself, several times the mass of Jupiter, orbits a sun-like star. But as it passed in front of its star, astronomers noticed peculiarities in the light curve. The transit had subtle, additional dips in brightness before and after the main event. the most compelling explanation was not a second planet but a massive moon. This candidate, dubbed Kepler 1625b, would be the first potential exomoon ever detected. The scale of this object is staggering. The data suggests a moon roughly the size of Neptune. To comprehend that, imagine our own solar system. Our largest moon, Ganymede, orbits Jupiter and is about half the size of Earth. This candidate is a giant, a world that would dwarf every moon we know, orbiting a planet over 8,000 light-years away. Its proposed orbit is equally vast, placing it a tremendous distance from its host planet, a wide, slow dance that takes it nearly a month to complete. The implications are profound. For such a colossal moon to exist, it likely did not form in a circumplanetary disk the way we believe the moons of Jupiter did. Instead, it may have been a planet in its own right, captured by the immense gravity of Kepler 1625b in the chaotic early days of the system. This is a story of cosmic theft where a gas giant seized a smaller world and made it a permanent satellite. The discovery, while still awaiting definitive confirmation, opens a thrilling new frontier. If moons the size of Neptune can exist, what other lunar wonders are out there? It forces us to consider the potential for habitable exomoons. Imagine a rocky, Earth-sized moon orbiting a gas giant within the star's habitable zone. Such a world could have its own atmosphere, liquid water on its surface, and a sky dominated by the colossal, banded sphere of its parent planet. The day-night cycle would be complex, shaped by the moon's rotation, its orbit around the planet, and their mutual orbit around the star. While the candidate around Kepler 1625b is a gaseous giant itself and not habitable, its very existence proves that the architecture of other solar systems can include moons of planetary scale. It suggests that for every strange planet we catalogue, there may be an even stranger moon waiting in its shadow, a hidden companion with its own secrets to tell. The possibility of a giant moon opens our eyes to hidden companions, but the most profound search remains for a world that could harbor companions of a different kind. LHS 1140b stands as one of the most promising candidates we have ever found in the hunt for life beyond Earth. This is a super-Earth, a rocky planet with about 6.6 times the mass of our own world, orbiting a small, cool red dwarf star. Its orbit places it squarely within the star's habitable zone, that delicate region where temperatures could allow liquid water to exist on a planetary surface. But what makes LHS 1140b so exceptionally compelling is not just its location, but the nature of its sun and its own characteristics. Unlike many volatile red dwarfs prone to sterilizing flares, LHS 1140 is remarkably quiet and stable for its type. It is an old, calm star, which means the planet has likely enjoyed billions of years of relatively gentle radiation, a crucial factor for allowing any potential chemistry for life to develop and persist without being constantly scrubbed away by stellar tantrums. The planet itself presents a fascinating mystery. With its mass and size, it sits right on the boundary between two very different kinds of worlds. It could be a massive rocky planet, a true super-Earth with a solid surface, potentially continents, and a substantial atmosphere. Alternatively, it could be a mini Neptune, a world with a small rocky core enveloped by a deep, dense atmosphere of hydrogen and helium, making it more of a gaseous world than a terrestrial one. This is the critical question that next-generation telescopes like the James Webb Space Telescope are poised to answer. The planet is a perfect target for such study because it transits or passes in front of its star from our point of view. These frequent, predictable transits allow astronomers to perform transmission spectroscopy. As starlight filters through the planet's atmosphere during a transit, different gases absorb specific wavelengths of light. By analyzing the resulting spectrum, scientists can detect the chemical fingerprints of molecules like water vapor, methane, carbon dioxide, and even oxygen. Finding such a combination in the atmosphere of a rocky world in the habitable zone would be a landmark discovery, a hint that biological processes might be at work. Imagine the surface of this possible world. If it is a rocky super-Earth, its gravity would be significantly stronger than ours. A person weighing 150 pounds on Earth would feel over 300 pounds here. The landscape could be dramatic, with towering mountains and deep valleys shaped by that intense gravity. The sky overhead would be tinted a perpetual deep red from the dim, cool sun, and that sun would appear much larger in the sky than our own, hanging motionless in one spot because the planet is almost certainly tidally locked. The most temperate region would be in the eternal twilight of the Terminator line, a band of endless sunrise or sunset where liquid water could pool. LHS 1140b represents a convergence of hope and scientific opportunity. It is a world with the right ingredients around the right kind of star that we are now capable of investigating in unprecedented detail. It is not a guarantee but a promise, a single point of light that holds perhaps the best chance we have yet to find an atmosphere, and just maybe a signature that we are not alone in the cosmic ocean. Lava defines the very nature of K2141b, a world so extreme it has perfected a cycle of geological violence. This rocky super-Earth is locked in a close, searing orbit around its star, with one hemisphere forever facing the stellar furnace. The result is a dayside so hot that temperatures soar beyond 3,000 degrees Fahrenheit. Here, the surface is not solid ground, but a permanent, churning ocean of molten rock, a magma sea spanning nearly 2/3 of the entire planet. The heat is so intense it does more than melt rock, it vaporizes it. Minerals like sodium, silicon monoxide, and silicon dioxide are boiled directly from the lava ocean, rising into the sky to form a thin, tenuous atmosphere. This is not an atmosphere of nitrogen or oxygen, but a shimmering, scorching haze of vaporized stone. Then, supersonic winds, born from the staggering temperature difference between day and night, sweep this mineral vapor toward the eternal darkness of the night side. On that frigid hemisphere, temperatures plummet to -300 degrees Fahrenheit. In that deep, airless freeze, the rock vapor cannot remain a gas. It condenses, solidifying directly out of the alien sky. The precipitation on this world is a relentless, gritty hail of pebbles and stones, a rocky sleet that falls onto a frozen, volcanic landscape. But the cycle does not end there. This rock rain accumulates on the cold, solid surface, building up along the shores of the lava ocean. The planet's own rotation and the immense gravitational tides from its star then likely cause this collected material to slowly slide and sink back into the incandescent magma sea, where it is melted and vaporized once more, feeding the atmosphere to begin the brutal process all over again. It is a world with a weather system made of geology, a vicious, closed loop where the planet is constantly cannibalizing itself, turning its own crust into atmosphere and back again under the glare of a relentless sun. This is not a planet of change, but of perpetual, furious stasis, a monument to the raw, unyielding power of heat and gravity. While K2141b is a world of relentless self-consumption, a mere 12 light-years away lies a stellar system offering a far gentler and perhaps more hopeful prospect. Teagardens star is a cosmic whisper, a faint red dwarf so dim it was only discovered in 2003, despite being one of our Sun's closest neighbors. Around this ancient, quiet star, astronomers found not one, but two rocky worlds of profound interest. Teagardens star B and Teagardens star C are both roughly the mass of Earth, and both orbit within their star's optimistic habitable zone. This places them in that rare category of worlds where, given the right conditions, liquid water could theoretically exist on their surfaces. The star's calm nature is key. Unlike many volatile red dwarfs that erupt with life-sterilizing flares, Teagardens star is exceptionally stable and old, meaning its planets have likely enjoyed billions of years of consistent, gentle starlight, a crucial foundation for any potential chemistry of life. The dimness of the star creates a fascinating paradox. These planets orbit much closer to their sun than Earth does to ours, with years lasting only about 5 and 11 days respectively. Yet, because the star is so faint, the amount of energy each planet receives is remarkably similar to what Earth gets. From the surface of Teegarden star C, the most promising of the pair, the Sun would appear about 10 times larger in the sky than our own, a vast, dull red orb hanging motionless overhead, as the planet is almost certainly tidally locked. This creates a world of permanent geography. One hemisphere basks in eternal, ruddy daylight, while the other is plunged into endless, frozen night. The most likely place for a temperate environment is the narrow band between these extremes, the terminator line. Here, the star would perpetually sit on the horizon, casting long shadows across a landscape of eternal sunrise or sunset. In this twilight ring, temperatures could be just right for liquid water to pool, perhaps in vast, shallow seas warmed by the constant, low-angle glow. The atmospheric question is everything. Does Teegarden star C have a thick enough blanket of gases to distribute heat from the day side to the night side, softening the harsh extremes? Could it possess a magnetic field to shield its surface from cosmic rays? These are mysteries future telescopes will aim to solve, but the very possibility is electrifying. Within our own galactic neighborhood, a short hop in cosmic terms, there exists a system with not just one, but 2 Earth-sized worlds in the Goldilocks zone of a quiet, old star. It suggests that the basic recipe for a habitable environment might be more common and closer than we ever dared to hope. What might evolve under a perpetual, crimson sunrise on a world that has known stable sunlight for twice as long as our own Earth has existed? Just 12 light-years from the hopeful twilight of Teegarden star, another red dwarf holds a title of profound significance. Proxima Centauri b is the closest known exoplanet to our solar system, a world orbiting the star nearest to our own sun. This proximity, a mere 4.2 light-years away, transforms it from a distant point of data into a tangible destination, the first stop on any hypothetical journey to the stars. The initial measurements are thrilling. This is a rocky world with a minimum mass about 1.3 times that of Earth, placing it firmly in the category of a terrestrial planet. Even more compelling, it orbits within the habitable zone of its diminutive sun, receiving just enough stellar energy that liquid water could, in theory, exist upon its surface. For a brief, glorious moment, the headlines wrote themselves, an Earth-sized neighbor right next door, potentially awash in the one ingredient we deem essential for life. But the reality of Proxima Centauri b is a masterclass in cosmic compromise, a story where every promise is shadowed by a formidable challenge. Its parent star, Proxima Centauri, is a tempestuous red dwarf prone to cataclysmic superflares. These eruptions blast the planet with X-rays and ultraviolet radiation at levels hundreds of times greater than what Earth receives from our Sun. Such fury could strip away a planet's atmosphere over time, scouring its surface bare and bombarding any potential chemistry with sterilizing energy. The second great challenge is a consequence of orbital intimacy. To be warm enough in the faint light of a red dwarf, the planet must huddle close, completing a year in just 11 Earth days. This proximity almost certainly means it is tidally locked. One face of Proxima Centauri b is forever turned toward its angry red sun, a hemisphere of permanent, scorching daylight. The opposite side is an airless, eternal night, a frozen wasteland where any atmosphere would collapse into ice. The only region with a chance for moderate temperatures is that narrow ribbon of perpetual twilight, the terminator line where the star forever hangs on the horizon. Could life persist in such a place? It would require an atmosphere substantial enough to redistribute heat from the day side to the night side, and a powerful magnetic field to deflect the relentless stellar radiation. From the surface of this possible world, the sky would be a dramatic and alien canvas. The sun would appear 3 times larger than our own, a vast, dull crimson disk hanging motionless in one part of the sky, its surface occasionally scarred by titanic flares visible to the naked eye. The landscape in the twilight band could be a world of deep reds and long shadows, with possible ice sheets creeping from the dark side and evaporative mists rising from the warm side. Proxima Centauri b, therefore, is not a simple paradise. It is a symbol. It represents both our soaring hope that habitable worlds could be astonishingly common, even in our immediate neighborhood, and the sobering harshness of the cosmos. It is a test case for resilience, a question written in rock and radiation. As we conclude our tour of 25 strange planets, this closest of neighbors stands as the ultimate invitation. It is a real place with a real address in the galaxy, waiting just over the interstellar fence. It embodies the entire journey, the wonder, the violence, the mystery, and the relentless human drive to understand what lies under an alien sun. The search does not end here, it begins next door. From scorching diamond cores to frozen worlds of styrofoam density, the universe has revealed itself as a gallery of impossible wonders. Each of these 25 strange planets is a chapter in a story far grander than any fiction, a testament to the boundless creativity of cosmic physics. We have witnessed worlds born from stellar corpses, oceans of molten rock, and atmospheres that rain gemstones. We have found hopeful candidates in the gentle light of quiet stars, and survivors clinging to existence in the heart of stellar infernos. This astonishing diversity does more than catalogue curiosities. It fundamentally rewrites our definition of a planet. No longer can we think of them as simple spheres of rock or gas following predictable orbits. A planet can be a diamond, a global lava lamp, a puffed-up phantom, or a naked core stripped bare. It can orbit one sun, 2 suns, or a dead pulsar. The very word planet has expanded into a universe of possibilities. This journey is just the beginning. With every new telescope, from the James Webb to the next generation of observatories now on the drawing board, we peer deeper and see more clearly. What other masterpieces are waiting in the dark? Could the next data point reveal a world with forests under a binary sunset, or a moon with ice volcanoes orbiting a ringed giant? The only limit is our curiosity. If this exploration of cosmic mysteries has ignited your wonder, imagine what we might discover tomorrow. Stay curious, look up, and join us as we continue to unravel the greatest story ever told, the story of everything that is and everything that could be.